Hi, welcome to my video on the slope of a tangent, which can be positive, negative, or zero on a polynomial function or a conic function of circles, parabolas, etc. Let's look at number one here. We have a parabola which is opening upward, which means the A is positive, and we want to look at a tangent at points A, C, and B. If we draw a tangent at point A, the tangent is coming down and touching the parabola at one point A. So the slope of this tangent is negative because it's going up to the left or it's going down to the right. So the slope of that tangent at A is negative. The slope of the curve is also the slope of going to be the slope of this tangent, which is going to be negative. More to come on that. We're explaining in more videos. And the values of x anywhere on this side. So notice that the vertex here is x is 0, y is 1. So anywhere on where x is less than 0, the slope of this tangent, no matter what point we pick to the left of 0, the slope of the tangent is negative, and the slope of the curve is going to be negative. Not like a secant. A secant passes through 2 points of the curve, but the slope of this secant is not the slope of the curve, but the slope of the tangent at this point will be the slope of the curve. Let's look at C. C is right here, and we draw a tangent at C like this, and we have a horizontal line. The slope of this horizontal line is 0, so the slope of the curve is 0, and this value occurs at x is 0. Let's look at B. B is here, so let's draw a tangent at B. Remember, tangent touches it at one point. So there's a tangent touching it at one point. So the tangent is positive. So that means that the slope of the curve is going to be positive. And the slope on this side, the slope of any tangent on this side, which is x is greater than 0. So whenever x is 0 in this parabola, we have a positive tangent. Slope is positive of the tangent, and the slope is positive of the curve. When the slope of the tangent is 0, the line is oblique, horizontal, or vertical. When the slope of the tangent is 0, so it will be slope of the tangent is 0, it will be a horizontal line at the vertex of the parabola. So a tangent, the slope of a tangent is 0. It has to be 0 slope, has to be a horizontal line, and that will occur at the vertex. So let's illustrate that. State the value of x for which the slope of the tangent is 0. So the slope of the tangent is 0 is at the vertex. So what's the vertex of this parabola? The vertex is x is 2, y is 3. So when x is 2, the slope of the tangent will be 0. And just to illustrate that in the diagram, the vertex is 2, 3, like that. And the parabola will go up. Why do I know it's going up? Because this is positive. So if you put a 1 in, or a 3 in, or a 0 in, you'll get points up here. So this occurs at the x coordinate of the vertex. Now we have another one here. So there's two ways we can do this. To get the x coordinate vertex, we can do x equals negative b over 2a. That's the fast way to do it. That's a, that's b, and that's c. So that's a negative. B is 12, so negative 12 all over a is 2. So that's negative 12 over 4, which is negative 3. So right away, this is the x coordinate of the vertex, and the x-coordinate of the vertex is where the parabola would have a tangent with a slope of 0. And another way to find that is to, if we complete the square, we do it this way. Let's take the 2 out, x squared plus 6x. So now we'll complete the square, x squared plus 6x, and we'll half of 6 is 3 squared is 9. So we put a 9 on here, but 2 times 9 is 18. So to balance it out, we put negative 18. So y equals 2 times x. Perfect square trinomial factorable is x plus 3 squared minus 19. So the vertex of this parabola is negative 3, negative 19. And again, it's plus is opening upward. So it's occurring at x equals negative 3. So if we did it this way, you would say negative 3 because that's the x-coordinate vertex. If you did it this way, this is the x-coordinate of the vertex. It's also the axis of symmetry at the same time. So we didn't have to do all this work if you know this little fact here. So let's continue. Draw y equals negative x plus 1 all squared plus 3 on the grid. Well, right away we have a vertex of negative 1, 3. The vertex is opposite of this one, which is negative 1, so y is 3. So negative x is negative 1, y is 3. So the vertex is right there. That's the vertex. And because this is negative, it will go downward. So let's take when x is 0, put a 0. So let's put a 0 in here. Okay, put a 0 in. 0 plus 1 is 1. 1 squared is 1. Negative 1 plus 3, you get a 0, you get a 2. So when x is 0, y is 2. So you can see it's coming down from this vertex. And let's put a negative 2 in here, because that's the axis of symmetry is x equals negative 1. So we put this is 1 to the right, this is 1 to the left, so this should give me also give me a 2. So let's check it out. Put a negative 2 in here. Negative 2 plus 1 is negative 1. Negative 1 squared is 1. Negative 1. Negative 1 plus 3 is 2. So you can see that it's opening like this. There it is. Now, if I let y equals 0, I can solve this out and get the x-intercepts. But this is a vertex of negative 1, 3, and because it's negative, it opens down. So there it is. Use the graph to explain what the slope of the parabola is at x equals 1. I'm going to use the graph. Y is the slope to explain what the slope of the parabola is at x equals 1. When I mean what the slope is, I mean this is the slope positive, 0, or negative, because we have to do more math to find out what the slope is at 1. So 1 is approximately right here. So what is the slope of the parabola at x is 1? So this point here, where x is 1, the slope of the parabola is also the slope of the tangent at x equals 1. So the slope of this tangent is coming in, touching it at one point, and moving on. So there's the tangent. So that's the tangent. Cutting the graph at x equals 1. We don't need the y value. Well, we can plug a 1 in here and get what this y value is. Put a 1 here, we get what? 1 plus 1 is 2. 2 squared is 4. Negative 4. So you can see that when I put a 1 in, I got it in the wrong spot. So when x is 1, I said it was up here. But I just did an estimate. So 1 gives me a 2, 2 is a 4, a negative 4, so there's negative 1. So 1 is a negative 1, so that means the graph doesn't go through here like this. The graph comes down, it comes down like this. So if I plot more points, so really, negative 1 is negative 1, that's that point there. So really I should be talking about the tangent right here. This is only an estimate. But the slope of this tangent is negative. The slope of the parabola is the slope of the tangent, and it's going to be negative. So if I plot more points, if I found the x-intercepts and plotted more points, then I would realize that this point right here is x is 1, y is negative 1, and the slope of this tangent is negative, so the slope of the curve is negative. So negative is the answer. If x was 0, if the slope of at x equals negative 1, the slope of the curve would have been 0. The slope of the tangent would be 0. And if x was negative 2, this point here, then the slope of the tangent would be positive. The slope of the curve at this point would have been positive. So it's negative, and that's why. Because the slope of the tangent is also the slope of the curve. We're going to see that coming up in further videos. And again, if you like my video, click the like button, click the subscribe button. Visit my website, www.mathsfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained, just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.